Welcome to the Heart of CIRS podcast. I'm your hostess, Melanie Joy Pensack, here to share heartfelt conversations with folks recovering from CIRS and with those special people serving the CIRS community. The podcast was created to help bring awareness to the physical, emotional, and mental experiences of folks navigating CIRS day to day. The world needs to know what CIRS folks go through for deeper empathy and understanding. Through stories and vulnerability, we can help the world understand the winding journey of CIRS recovery. Thank you for being here to open your mind and to open your heart. Hello, everybody, and welcome back to the Heart of CIRS podcast. I am very excited today to have Christian Navarro-Torres here again. He is somebody that was in the first season of the Heart of CIRS podcast, I believe actually my first interview. And so I'm very excited that he is back here again today to talk with us about a different topic, research today. If you want to hear about Christian's CIRS journey and some of his thoughts and predictions on CIRS as an illness and what it looks like in the world, I definitely recommend going back and listening to that first episode. And for today, I want to welcome Christian back to talk all things research. Welcome, Christian. It's good to have you here.
Thank you, Melanie. It's always a pleasure. Very excited to be doing this, and maybe we're creating a sort of a new arena or space to start thinking a little bit more scientifically about the illness, but in a way, hopefully, that's accessible to the general population, because I think you and I are both committed to the idea of educating people on CIRS at different levels. And part of that is certainly be able to engage with some of the science behind it.
Absolutely. And to share with everybody a bit more about how this episode even came to be, there are people who have CIRS, and of course they have their CIRS doctors, but then they often have to interact with the more traditional Western physicians. Sometimes this is because they need to have blood work drawn from their primary care so that insurance might cover it. Or sometimes there are downstream effects from CIRS that then need to be addressed by a specialist. So maybe that's a gastroenterologist, maybe an endocrinologist, neurologist. Sometimes we have to enter into that Western world to rule in, rule out anything that might have developed as we go through the CIRS journey. And what I'm seeing with some of the people that I talk to and work with, and even in my own experience dealing with some of these physicians, there is more acknowledgement of the illness when the patient comes in and is able to speak to it scientifically in the language of the doctor. And my hope is today, if you're one of these people who needs to interact with a non-CIRS physician for whatever reason, that you're going to feel like you have some skills and language to take a research study that is explaining CIRS and some of the effects. And so you can show this to that doctor and say, hey, this is what I have, and this is some of the key points, and I'd really like you to read this to know what we're dealing with here. Because I find that the doctors also pay attention to you a little bit more when you go in empowered versus disempowered.
That's exactly right. And I've had this situation myself. Unfortunately, it happened before I knew I had CIRS, so I wasn't quite equipped. I didn't have the language or even the awareness of the scientific literature behind CIRS to convey this. But once I realized I had CIRS and I started, talking to other patients, helping them, this became a very important piece of my hope of helping people, is just to try to give them some basic skills or just awareness of, here are some studies that you can refer to when you're talking with your non-CIRS practitioner. And I've had moments personally with that when that has worked pretty well, and other times it's a little bit more challenging. But the important thing is that you have the opportunity to engage with your practitioner and then take it from there.
Before we get into the research paper today that we're actually going to break down and walk you through how to look at a research paper and how to look at one of the CIRS research papers that you could take to another doctor, we want to hear a little bit more about Christian's research background. We didn't go too much into that in our earlier episode. It was more about your personal CIRS journey. So I'm just curious, how did you get into research?
Yeah, it's a great question. There's definitely a lot of embedded chapters in that process because a lot of people who go into research, they're not thinking when they're 8 years old, oh, I want to do research. Most people don't. It's something that sort of emerges over time. For me, it started to emerge when I was in college back in Puerto Rico. I'm originally from Puerto Rico. I was studying philosophy. So I have a very strong humanities background, and I think that's still very important to this day in my formation, in my academic formation. But I started to become really interested in topics that had to do with the brain, psychology, cognition, mental illness. Back then, I thought of it a little bit more in the clinical sense. I was really interested in clinical psychology, but I was also really interested in all of this neuroscience jargon that I kept running into. And I kept reading all these sort of more pop scientific books and articles on different topics related to the brain and perception and all kinds of interesting disorders. The one that stood out to me was synesthesia. That was really an entry point for me to really start thinking about the brain. And then over time, during my undergraduate years, I started to look for opportunities to gain some research experience. And I worked in a lab that was not doing anything related to neuroscience. It had to do more with sort of measures of being and stress in public schools in Puerto Rico. Nothing related to what I was really interested in, but I started learning or acquiring basic skills of how do you do research? How do you ask questions? How do you read things? What are the kinds of conversations that scientists have? So those are very basic skills that you start to acquire and you start understanding what it takes to become part of that. Eventually, I was really lucky and fortunate to get a federal research grant from NIH, National Institutes of Health, to work in a research lab at the University of Connecticut with a very well-known researcher that was studying autism in toddlers. And it was a really cool longitudinal study. A lot of money was put into it. And we were looking at different measures of linguistic ability and social skills, and we were tracking those over time. So I was interested in a lot of language related research back then. I was trying to see how can I integrate the language research and like the passion I had for cognitive science and neuroscience. And that was really my more formal entry point where I started to really get into data collection, training other students, data analysis, writing papers. I wrote my first paper that was rejected and I felt horrible. But actually, I go back to that, the reviews that I got for that paper submission that never got accepted. But the feedback and the learning experience was huge for me at that point. Fast forwarding, eventually I made my way to graduate school at Penn State University, where I started working as part of a large research center. It was called the Center for Language Science, where a lot of people were studying bilingualism. So that became my area of expertise in graduate school. What was really cool about this center at Penn State is that you had a lot of people coming from different disciplines: neuroscience, cognitive psychology, linguistics, applied linguistics, education, computational science, who were interested in studying bilingualism. I was in the cognitive psychology department, so my entry point was thinking about cognition, things like memory, attention, language, and their relation to brain function and brain structure. That was my main source of training as a graduate student. But overlaid on top of that, I was doing a lot of work that overlapped with linguistics, thinking about how languages come about, how they're structured, and the sounds, and how we create meaning, and all these things. But I was ultimately really interested in understanding the consequences of speaking more than one language. So becoming bilingual, how does that impact your brain? That was really the question that got me very excited. And so that's what I did throughout my PhD. I did a lot of research, a lot of experiments. We would bring in participants to a lab and we would measure their EEG waves. For example, we would have them do a series of cognitive tasks or language-based tasks, and then we would perform all kinds of analyses and we would publish that work. And so that was basically my graduate school. And shortly after that, I started a postdoctoral research position at Princeton University, where I was trying to specialize a little bit more on certain areas that were tied to my research background. And Penn State, which eventually became UC Irvine, that's really where I finished. I transferred from Penn State to UC Irvine in California to finish my PhD. Unfortunately, by the time I started my postdoc position at Princeton, that's when I became sick with CIRS. So it all converged, and from there on, my ability to engage as a profession, with research as a profession in the academic setting, started to become more constrained. I still continued to stay on the academic track, and then from there, I jumped into another postdoctoral position at Georgetown University, which was really much more geared towards the neuroscience piece. Princeton was a little bit more on the cognitive psychology and linguistics side in terms of training. Georgetown was much more geared towards neuroscience and even some clinical neuropsychology. So there were people there were researchers there who were also clinicians who were looking at patients with stroke and aphasia and things like that. Those were really important moments for further learning about certain things, even though I was sick with CIRS, so my ability to engage was somewhat limited. But I still was able to learn a lot during that process. Throughout all of this, I had so many different opportunities to present at conferences, obviously publishing, writing research grants, all of the things that you do in academia. And for me, all of those things were just very meaningful things at the time. That's a short summary of my academic trajectory.
Thank you for explaining. I'm sure people listening, they're going to hear that and think, wow, what a great addition to have in our CIRS community, somebody that really has been immersed in the research world from the get-go and understands the ins and the outs of all of the processes of what it takes to do a research study from the ground up. That's so important and needed for our community right now.
It is. This is one of the most important pillars right now in order to move forward the awareness of CIRS is the research front. We have already a literature that has been ongoing for the past 2 decades or so, roughly. And there's new research coming out, but with any kind of research domain, part of what's really important is dissemination of the research, not just coming from one community, but eventually making its way to different scientific communities who may be interested in the topic. And hopefully over time, what starts happening is you have other scientific communities jumping into this, trying to understand what is this illness that we call CIRS. And right now, the bulk of the research that has been published is coming from Dr. Shoemaker's group, which has been super foundational and important. And we're going to be going over one of these papers in just a moment. But ultimately, the ultimate goal is to really make this part of the scientific enterprise at large. So you have people from different universities and communities who are investing their resources, who are applying for research grants to continue studying environmentally acquired illnesses, and certainly CIRS as part of that.
Yeah, when people in the world, they talk about a lot of CIRS patients, they'll say, why don't the doctors recognize this? Or why are people in the different medical communities not talking about it? This is what you're pointing to as being an important piece to actually make that happen. Because we as CIRS patients, we can all see the interconnection on social media, for example, between all these people posting about IBD and gut illnesses and mast cell issues and you name it. And there's not a connection to that this could be a part of a bigger picture of CIRS. And to really make those connections, the research needs to reach different modalities in different disciplines, really, to then help other people out in the world make that connection for themselves.
Yeah, absolutely. That's spot on. That's exactly part of what's at stake with CIRS, but also with just really any sort of novel frontier on science. That's what you're always trying to get at.
Let's get into it then. Let's get into one
Yeah.
of these studies. I'm going to tell people, if you want to follow along with what we are talking about, now would be a really good time to pull up the research study that we're going to go over. I'm going to link it in the show notes. This particular study is Vasoactive Intestinal Polypeptide, VIP, corrects chronic inflammatory response syndrome acquired following exposure to water damaged buildings. It's by Shoemaker, House, and Ryan. That particular paper was published in
2013.
2013. Great.
Yes.
Christian is going to walk us through different parts of this research study, talk about the key points that it would be helpful to point out to another physician or another person, and help us just understand the different sections of a research study. What are we looking for there that's important? Take it away.
There's a couple of different ways to think about what makes a research paper a good quality research paper. And I would just say off the bat, no research paper is perfect. Every research paper that's ever been published has pros, it has very impressive and important contributions. And those same papers will also have limitations or even flaws. That's part of science. I always encourage people to never think about this paper is the definitive answer to any given question. Real science is an ongoing process, and you need multiple studies accumulated over time to start really getting a picture of what is it that you're trying to look at and understand from a scientific basis. I think that's really important always whenever you're thinking about it. As a patient and as a person who's educated, and a doctor who's literate in reading papers should know this. They should know that it takes years of research to understand any given problem that we're trying to study. But with that said, there are some general features in a paper that are worth talking about in terms of qualities that I deem as positive qualities. Whenever you're looking for a paper, to try to get a sense, is this a paper that's worth sharing with someone else, with an academic or with a doctor in this case? And I think this paper that we're going to be going over, is a good example of a paper that meets some of these very important sort of aspects or criteria that I think are important to make a compelling case, say, hey, you should really pay attention to what this paper is trying to say. I'll go through a list, and then as I'm going through the list, we'll jump into parts of the paper as necessary. At a very general level, one thing you want to be looking for in a paper is that it's been published in a peer-reviewed scientific journal. And what that means is that this journal has a system in place where you have an editor, a chief editor, or an editor that's part of the journal that's been assigned to identify papers that would be appropriate for that journal. And so what that editor would typically do is, once they get the submission from the paper, gets assigned to a number of anonymous reviewers, again, chosen by the editor based on the topic of the paper. These reviewers are supposed to be experts in that particular area. Sometimes editors will bring in outsiders just to have an outsider opinion on the paper. The basic idea of reviewers is that they provide qualitative feedback, and then the editor needs to make a decision about whether they're going to reject the paper, whether they're going to recommend it for publication, or whether there needs to be revisions that need to be made based on those reviews. This is ultimately based on the judgment of the editor. It's not a perfect system, but when it is implemented properly, it can really elevate the quality of the paper. The converse is also true. When this is implemented poorly, it can really downgrade the quality. And so that can vary quite a bit across journals and even like editors. And the take home here is that this is a paper that has been peer reviewed. It is in a journal that has peer review as a feature of that process. So that's a good sign.
How do you know that
Yeah.
about this paper if you were just looking at the download?
That's a great question. Typically, if you go to the website of the journal, this journal is called Health. You look for a general overview description of the journal, it will typically say it is peer reviewed explicitly. Or if you're an author and you're interested in submitting an article, there's usually a section on the website where you go into the specifics of what they want, what is their criteria for submitting an article. And usually those sections will also include some information about having some kind of peer review process. So it's usually very accessible in that sense, in terms of being able to figure out once you go to the main page of the journal. And often, if you have access to the PDF version of the paper, very often, though not always, the PDF will have somewhere a link to the journal. In this case, in the paper, if you're on the very first page, at the very top, there's going to be some information on the upper left corner that says the volume number and all of that. And then there's a DOI link. If you copy paste that into the link, it will bring the paper into a website format. And from there, you can access, you should be able to identify the journal website. The other way to do this is, in this example, if you go to the bottom right corner of the first page, there is a little tab that says in red, openly accessible ads, and then there's a link there to the journal. So if you click on that, it will take you to the sort of main website of the journal. And from there, you can start exploring the different links. And again, there should be some information somewhere. It may vary depending on the journal and the design of the website, but it will, at some point, it will say it's explicitly peer reviewed, either in the general description of the website, in the website, or in the specific subsections where you're submitting an article. Moving on to another feature that I think it's just more like a standard practice. Peer review is standard practice. On that same vein, there are metrics that we use to get a sense of the quality of the publication in relation to the journal in which it's being submitted to. So there's a metric that we call the impact factor, or IF, for its abbreviation. And ideally, you want to be looking at journals that have this impact factor metric. And this metric is basically, it's based on how often the average article in that journal is cited in a given year. That's the rough definition of what the impact factor number is. For example, if the journal says it has an impact factor of 2.5, that means that on average, an article in that journal has been cited roughly 2.5 times. The impact factor number varies wildly across disciplines. So what's considered a low impact factor in a specific scientific community, it may be considered a high impact factor in another community. And I should say that the higher the number, usually that's deemed better, right? The higher the impact factor, that means that more people are seeing stuff being published in that journal. But like I said, it will vary wildly across disciplines. So there is no standardized scale or tiers of impact factor across disciplines. It really depends. And the other thing I'll say about this is that impact factor is not everything. You can have high quality and very important published studies in low impact factor journals. And you can also have low quality research that's published in high impact factor journals. But impact factor is a standard currency in the scientific world when it comes to metrics. So if you see that the journal has an impact factor, that already sets it apart from a journal that doesn't have it. So it's a low-hanging fruit in terms of quantitative metrics of the journal. I wouldn't worry too much about the number itself, and just more with the idea that the journal does have an impact factor metric included.
One question before you go on, tell me about the year. How do you want to look at journal articles in the year? Do you want it to be within 10 years, 20 years for it to really be considered and still being of impact?
That's a really good question. I think it really depends on the topic. In general, as a basic rule of thumb, the more recent the study, the more likely it has more direct implications and application to something that's currently happening. It's a good starting point, but there are cases where you'll find papers that were published 3 decades, 4 decades ago, and there's something very important to be found in those studies that hasn't been followed through properly. So
Yeah.
to some degree, the answer to the question depends on how much research has been uh, uh, done in that specific community or topic. If you don't have a lot of published research historically, then you may want to be a little bit more open about going back in time, even if it's a couple decades old. And that literature can still have very high relevance. If it is a research area or topic that's well disseminated, you might be better off trying to look for things within the last 5 years or so, if I had to say some kind of very general rule of thumb. But at a very general level, I would say anything within the last decade is usually going to be pretty relevant to whatever it is that you're looking at. And the reason, part of why I say that is because I've seen this in my field, that there's this weird, interesting phenomena that happens in terms of roughly every 10 years or so, there seems to be some kind of shift in some important way theoretically with that topic. And I saw that in my own field, where if you look at the literature between 2000 and 2010, there was like certain questions that were being asked. And then if you move from 2011 to 2020, there were another set of questions that were being asked that were more relevant to what's currently happening. That could be maybe a basic rule of thumb. Ideally, something within the last 10 years or so, give or take. It's not a hard cutoff, but it really depends on how much disseminated work historically has taken place in that topic.
That makes a lot of sense. Thanks.
So we talked about the peer review aspect. We talked about the impact factor metric. Now going more into the specifics of the paper. So those two factors that I mentioned are more very general, generic features, entry point features. So more specifically with the paper, when I'm trying to gauge a paper, I'm thinking at a very general level, is this paper overall well written and properly motivated? And this is what a lot of editors and reviewers are going to be looking for when they're making the decision of whether they accept this paper or not. Here's a really small detail that I think it's really important as an example. One thing could be thinking about the title. The title, does it capture the take-home message? People don't think a lot about that, but it can be very informative. And let's think about this title. Vasoactive intestinal polypeptide corrects chronic inflammatory response syndrome acquired following exposure to water damaged buildings. It's almost like a little story that's already packed there. So what I can infer from that title is that the paper is about this peptide called VIP and how it impacts the physiology of a specific clinical population. So I have enough information to already create a picture of what this paper is about. And this title does that job. So that's really cool and important. I think for someone who doesn't have a lot of time, if you have a doctor who doesn't have time to read papers, they will look for the title just to see where this is going. So that's an important piece. The other thing that I would look for is the abstract, which is the very first part of any published paper. It's basically like a synopsis or a summary of the paper where you have a condensed version of what are the challenges of this literature, what are the gaps that are missing, so what's motivating the study. And then you proceed to describe what the study is about at a very general level. And then you briefly report some of the key findings in the abstract. And then you might have some kind of conclusive statement or sentence. Those are the basic features of the abstracts. And when you're in a hurry, and certainly with me, where I've read now probably, I don't even know, but it's been hundreds and hundreds of papers, you get into, okay, let me read the abstract. Let me see what this paper is saying. And so when the abstract meets those basic criteria for an empirical study, that's also a good sign that this is a paper worth checking out. So from there, you start getting a more cohesive picture. And from there, you can even jump to very specific parts of the paper without having to read the whole paper. This is certainly going to be the case for a doctor who knows how to read papers or for an academic who's seasoned. So I'm portraying this from their perspective, right? Yeah. They're going to want to read the abstract and see if they can get the gist of this paper. And those are some of the basic features. What is the motivation of this study? What is the study about at a very general level? What are the very basic findings? And what is the concluding remark, which usually has some interpretation into it, although not necessarily. But that gives you a sense of how these authors are thinking about this problem. So abstract, so we talked about title and then abstract, right?
I think that's helpful for people to know when they're pointing someone to reading it, they can use language from the abstract to make an impact.
Yes, absolutely. Absolutely. And so moving from there, if you want to go more into the weeds, then you start looking at the introduction of the paper and you start asking again questions like, is this study properly motivated? I'll give you an example of the paper. We're still on page 1 here of the publication of the PDF format in the section where it says introduction. The introduction right away identifies a gap in the literature. What are those gaps? In the very first paragraph, actually the very first sentence, it basically, I'm paraphrasing here a little bit, it basically says that the treatment of this multi-symptom illness that we call CIRS from water damage exposure has remained problematic until recent years, but really up until this point in 2013, it's been an ongoing problem. And the authors state 2 reasons for that being a problem. One is no consistent pathological mechanisms had been demonstrated. And then the second reason is that there are no biomarkers that have been consistently identified, thereby preventing confirmatory laboratory diagnosis. So if we want to just rephrase that, they're identifying 2 gaps in the literature. Number 1, there's a lack of biomarkers that differentiate CIRS from other illnesses. And number 2, there's no hypothesized causal mechanism that has been put forth to explain CIRS. Already, so this introduction is doing a really good job at motivating this study, right? And so we have that as a motivation already. So if you're a doctor reading this should start getting you hooked into the story of this study, essentially.
And people who are patients, this is what's going to get them to buy into them maybe writing the blood labs that you need, because you're the one saying, hey, I need these blood labs written. And they might be like, why do you need TGF-beta1 or MMP9? And it's already starting to show the doctor that these are the particular labs that you need for this illness.
Exactly, because they pointing out these limitations in the literature already tells you that they're going to be trying to address these issues.
Yeah.
That's right. That's the foreshadowing of an introduction in a scientific paper. There always is going to be some kind of foreshadowing of, if you're pointing out a certain limitation or gap in the literature, it's because you're going to try to address it. So what they're trying to address is, we want to try to come up with biomarkers that differentiate CIRS from other illnesses. And we want to try to think about what could be some of the causal mechanisms that are leading to this illness, right? And especially they're going to be really focusing on the first one, the one about identifying biomarkers. And then the third piece, really, which is the big piece of this study, is that they're running an clinical longitudinal study where they're going to see if a certain treatment intervention can impact or correct the abnormalities or the abnormal biomarkers that these doctors have identified. So there's really a third layer there that sort of becomes more explicit throughout the introduction. That's the ultimate goal, is to see this specific treatment, specifically vasoactive intestinal peptide, VIP, does it help improve these biomarkers that we have identified that are problematic in CIRS patients? That's really the goal of this paper. And it's, if you go through the introduction, we don't have time to go through the whole introduction. That's the unfolding of the introduction. It's working their way towards motivating that question about whether VIP helps restore these biomarkers. And then there are layers to that throughout the introduction. They will talk about the fact that there are current treatments for CIRS that provide symptom relief but they're lacking full correction of these biomarkers and restoration of immune dysfunction, which is at the heart of what CIRS is, right? CIRS is an immune dysregulation problem. And that's what they're trying to get at here is we've come up with a protocol up until now. Remember, this is 2013. So VIP wasn't quite settled in stone as it is today. So they had the other steps, the other 11 steps that start with removing the patient from exposure, taking a binder like polystyrene Welchol, clearing mark-ons, et cetera, et cetera. But none of those treatment steps seem to really get to the heart of the problem of CIRS, which is correcting the immune dysregulation. And this is what this paper is trying to showcase in an empirical fashion.
I had a physician, my primary care, when I was stuck in Boise, Idaho, who was very concerned that what I was doing was going to have a negative impact on me, that it was unethical or unstudied in some way. It was a point during the pandemic where people are questioning everything, right? So he's like, is what you're involved with legitimate? And I feel like this whole introduction really lays that out very clearly, that it is well studied and looked at, and this is the path for somebody who might be skeptical.
Yes, and to piggyback on that, one of the features that I'm looking for also on a paper usually is there relevant literature that's being cited outside your own work? And the paper does have it references other empirical studies that are relevant to this purpose. And I'll give you an example. If we go to the second page, which is technically page 397 in the paging layout of the volume, it's the second page of the PDF. If we go to the very last sentence on the left column, right before the method section, there's a sentence here that says use of VIP in a 28-day study has successfully been employed to restore immunoregulation in sarcoid patients. And then they cite a paper, a study that did this. And this is really important because this is an empirical basis to motivate the use of VIP. So it's not that these doctors are just out of the blue thinking about VIP where they could be thinking about a million other things to try, right?
Yeah.
And so what this is showing is that they have a motivation to think of VIP as an ideal candidate treatment intervention to correct this, because there's a previous longitudinal study that shows that VIP can restore immune regulation in sarcoid patients. These are patients who are suffering from granulomas, essentially. And there seems to be a lot of convergence in terms of what these patients, the sarcoid patients, show in terms of immune dysregulation, and what CIRS patients seem to show based on the clinical observations that Dr. Shoemaker and his colleagues were showing. So this is an example of a paper, this paper citing relevant empirical literature that's outside their own work. And again, that's a very good feature. And hopefully someone who's literate about these things, they'll start picking up on these things and say, okay, this is giving the whole story more weight in terms of what they're going to be talking about. So yes, I think that probably covers the introduction. It's basically you're setting up a story of what is it that you want to where you're looking at in this paper. So hopefully what you're doing in the introduction is you're convincing the reader why this is important, what led to motivating you to pursue this question or this problem. And I think this introduction does that pretty well. So we can perhaps move on to the methods section. And in the methods section, this is a very descriptive section in any research paper, but it's required. This is where you essentially start describing, again, it's very descriptive. It's not meant to be very narrative or very aesthetically ornamented. It's just very cut and dry. Who are your participants? Who are your subjects? What is the study design? What is the study procedure? And then you try to provide as much detail in a very descriptive manner of each of these things. For our purposes, some of the key things to note about the methods section here is that we have a participant characterization. So we want to know who are these participants, or who are these patients, or who are the participants that are participating more generally, because we have healthy controls participants in the study, and that's really important. But we have in this study a total of 20 patients who were diagnosed with CIRS. They talk about, and let me actually refer to the paper. Again, if we go to that second page, on the right column at the top, they basically say 20 patients, and then there's some demographic characteristics, ethnicity, mean age, and I think it's gender is also implied in this description. Those are the basic characteristics of these patients. You always want to see that in a paper, some kind of basic description. Certainly, you want to tell people how many patients participated in this study.
Why is it important to have a control?
That's very pertinent for in the context of a study design and thinking about what is this design. And the basic layout of this design is it's a longitudinal design for the patients. The CIRS patients are going to be evaluated over the course of roughly 18 months. And there's going to be 3 time points for them. There's going to be 1 time point for all the treatment steps prior to VIP. They're going to measure all these biomarkers that are specific to CIRS. They're not specific, but they're used to diagnose and monitor CIRS. And then there's going to be 2 intervals of VIP administration. There's a first time point before VIP treatment. Then there's a second time point 12 months after VIP, and then 18 months after VIP. There's 3 time points for patients. And what you want to see is basically, how do these biomarkers that we use in CIRS change over time as patients are going through this VIP administration? Okay, so that's one part of the equation in this study. But then what you can ask is, if you want to take this design to a step further, what you can do is you can bring in a control group that gives you a sense of what do these biomarkers look like when you're a healthy person. That's really important when we are trying to interpret results. Having some kind of control condition, it could be an experimental condition, or it could be comparing different groups, right? Because that helps you interpret the data. If you don't have control conditions or a control group, the interpretation of the data, there could be, you allow yourself to entertain multiple interpretations. So, right, and in this context, if you don't have a control group of healthy people, and then we look at their biomarkers, if we don't have that, then we can entertain different hypotheses of why the biomarkers are changing for CIRS patients. But we want to be very precise on how to interpret these. We want to be able to say, oh, they're changing, and they're changing in a way that's consistent with what a healthy person looks like. So now we can make a stronger inference of how to interpret these changes in biomarkers. So we have 20 patients, and then we have, I think, about 150 control participants that were tested prior at the clinics that sort of were used to bring in these participants to participate. A couple comments about the study. So sample size is an important feature or an important characteristic in studies. Here we have 20 CIRS patients, and then we have 150 control patients. As a general rule of thumb, a lot of people will say the larger the sample size, the better. That's not always true. It really depends on the research question that you're asking. In this case, the sample size of 20, I think it's very valid. And the main reason why it's a reasonable number, number one, it's really hard to get good quality data from many subjects, especially when it involves like clinical interventions, right? And especially when they involve a longitudinal design, which means this is a study where they're measuring biomarkers at multiple time points. So it's not just that they're measuring these biomarkers at one time point for the patients. Mm-hmm. So it's hard, number one. And number two, I already alluded to this. This is a longitudinal design. And with longitudinal designs, there's more flexibility in the sample size. You gain what we call more statistical power versus if you just had a study where you just compared a group versus another at one time point. With longitudinal studies, you can sacrifice the sample size, so you can have a relatively smaller sample size, but your ability to detect a significant change or a statistical effect that's relevant, it goes up because you have multiple time points. So I think that in that context, this sample size is appropriate given everything that's at stake here. And the fact that we have 3 time points where we're remeasuring these patients, it gives you more confidence that what you're finding and what you're seeing is not a fluke. It's actually genuine.
Wondered with the lower number, like why it's valid when it is lower. Like 20 to me, I'm like, is that a lot?
There are statistical procedures where you can conduct what we call power analysis. So you can run a statistical program that where you put in the hypothesized numbers that you would need in order to get a statistically significant result. And that analysis can tell you, okay, if you want to get this level of confidence in your results, you would need X number of subjects or participants or patients. That's one way to do it. It's one, but the other way that some of this just is really driven by conventions. What is appropriate in a clinical setting? There's going to be studies where they'll do 3 patients or 5 patients. And of course, the smaller the sample size, the more constrained you are in the types of statistical analyses that you can do. I can tell you for this particular study, a sample size of 20 is enough to perform the statistical analyses that were chosen. And you would get reliable statistical results in that sense. But it really depends on their research area, what is considered appropriate. Someone can say, play the devil's advocate and say, this sample size is a little bit on the small end. But what I would say is yes, but number one, this is a clinical intervention. So those are not going to be so easily very high on sample sizes. And number two, it is a longitudinal design. Therefore, you have multiple time points, so your statistics become much more reliable. Statistically, the level of confidence that these results are not a fluke go up exponentially when you add multiple time points. That to me is okay. They have a design here that I think it's very reasonable and it's worth looking at in terms of the results. That will be my conclusion from this.
Interesting.
Maybe what we could do now is jump into some of the results. So we're not going to go over all of the results. There's different graphs and figures, but what I want to do is focus on what I think is the most important set of results. If you had to point your doctor in a very specific part of the paper, where would that be?
Yeah.
I think the most informative part of this section in terms of the results is going to be found on table 2. Table 2 is it page 4? I think it's on page 4, right? Figure 2 is on page 3 or page 398. But if you go down to the next page, you're going to see table 1, which is a giant table, which is very informative. But table 2, which is right below that giant table, is, I think, the most informative table where you have a summary of the most important results. And you have everything here to make an informed conclusion of what this paper is trying to show. That's why I'm choosing table 2. If you had to pick just one thing in terms of results for your doctor to see, this is where I would go. Are we both on the same page, table 2?
Page 4 or page 399?
It's page 4, and it would be page 399 using the volumes. Yeah, right. This table 2, it has 6 columns total. The first column says lab in uppercase, and then under that, what you have is the different biomarkers being listed. Every row is a different biomarker. And then what you have on the right to that is where it says control. Those are the values of each biomarker for the control group, which we said it was about 850 people, or I think it was exactly 850 people. So these are the values for each of these. For example, the first row where it says SX, that is meant to denote the number of positive symptoms based on the symptom cluster that we use to diagnose CIRS, right? We have a total of 34, I think, symptoms that are used to officially diagnose CIRS. This is showing the average number of symptoms that are present in the control group, and we see that number of 2.9. So on average, in these healthy patients, the average number of symptoms that pop up in that group is 2.9, just under 3. Now, if we go to the third column, which says base, that is the baseline assessment of the CIRS patients, the 20 patients that we measured. And off the bat, you can already see that on average, those 20 patients are showing 29.8, so basically about 30 symptoms on average. So you can see already there's a huge numerical differences in how many symptoms the healthy control group is showing versus the baseline assessment of the CIRS patients. By baseline, we mean at the very beginning of treatment or prior to treatment, I should say. How many symptoms are these people showing? Then what we can do is we can ask the question, how do those symptoms change over time as patients are doing this treatment, the Shoemaker protocol? Specifically or especially, how are those symptoms changing as VIP is being administered? And so that's where the last three columns come into the picture. So the column that's named AC2, that is at the time point where patients are doing all the Shoemaker steps prior to VIP. So steps 1 through 11, right? So they're doing binders, they're out of exposure, they're treating Marcons, they're correcting their hormones, they're doing all these things. And already you can see that the number starts to go down from 29.8 to 17.8, right? So you're already starting seeing a decline. But if you compare the 17.8 to the control, it's still not quite comparable. The numbers are not comparable. It's still significantly higher. And they do run statistical analyses, which I will plug in right now here. They run statistical analyses to confirm that these numerical differences are statistically significant, or to see if they're not statistically significant, right? So they have statistics and they report some of what we call p-values in the results section in the text. That's another sign that this is a paper worth reading. It does have statistical analyses, and the statistical analyses in my book, I find them to be reasonable. But moving on here into the numbers descriptively, so now we want to see, can we get that 17.8 further to further go down to the point where the number is statistically comparable to the control number of 2.9. So now we go into the fifth column and we have the 12-month time point, which is after 12 months of VIP administration for these patients. And now you see that the number is all the way down to 5.5. And so that starts getting really close to 2.9. And then at the 18-month time point, which is the last column, that number even goes down more, and it's 3.4. And if I remember correctly, if you read the text, what it will say is that certainly for the last time point, that 3.4 is no longer statistically different from the 2.9 from controls, right? So that's the very objective description of that result for symptoms. And what we can interpret from that is, because we have a control group, what we can infer is that the VIP treatment has significantly brought down the number of symptoms in these CIRS patients to the point where they're statistically comparable to control. So if you wanted to further interpret that, you'd say, oh, these people now are no longer sick based on symptoms, because the number of symptoms that they're showing on average, it's so low that it might as well just be like any other healthy person out there, basically.
I've just had so many light bulbs go off the way that you explained that. That was so helpful. I think it really, you hear people in the surviving mold community talking about this, but that really shows you how they get to the statements that they are making.
Yeah, exactly. And this is when I'm reading a paper, I have to go through that process, although all of this becomes very automated with more experience of just reading so many papers. This took us, 5 to 10 minutes to break down just the table and just do the first row. But for me, I'm already like scanning and I'm seeing these patterns. And then what I want to look for, is there any statistical confirmation of these numbers changing?
From the patient perspective, then, if your doctor is skeptical, you would show them this particular table and say, look, these are the symptoms that many CIRS patients have at the baseline level, but this is how many they show after 18 months, which is comparable to the controls. And you can do that with all of the biomarkers.
Absolutely, exactly. And we won't have time to go over each biomarker, but the same logic applies here with all of these other biomarkers, which are really blood markers. And you can see the same pattern. I'll try to pick just another one here. So I'll take MMP9, which is showing MMP9 levels in the form of nanograms per milliliter, and that's the ng/ml shortened version there. And what is that the controls have 332 as an average, which is within the lab reference range that LabCorp, for example, initially used to identify whether someone has an abnormal level of MMP9 or whether it's within range. So this 332 falls within the normal range of the established criteria that was used back in 2013 and that has been used throughout the history of these labs as far as I know. But then you compare that to 628, that's outside the reference range that's used in LabCorp. So this is abnormally high at baseline. But then look at how that number starts going down from 628 to 358 and then to 302 and 290. So now already even with the AC2 column where you're doing the first steps, you're basically entering within normal range with these patients, and it keeps going down. And at that point, really, any of those last three columns, statistically, most likely they're not going to be significantly different from the 332. So it's really at baseline where you see that elevated 628, and then it goes back to norm. And so this is the general pattern that you get from these markers. You're seeing these changes. They're statistically confirmed in the analyses, which is, again, a really good and important piece of seeing these changes, numerical changes.
The other thing that comes to mind for me is, as a patient, this is empowering to see this, because if you see at 18 months that your MMP9, if you've been on VIP, could go down to 290, and it's not, it is a cue to you and your doctor to investigate what the exposure is that's causing that to remain high. And
absolutely,
a whole nother podcast, but I feel like that is another point that people could really use to drive the investigation of a potential additional exposure or tick-borne illness or something.
Absolutely, yes. And that, as you said, that's definitely in the realm of another podcast, but
yeah,
certainly, maybe I should just say very quickly for the purposes of the podcast, I don't know, maybe a doctor will be listening to this at some point. If you're a doctor and you don't know what MMP9 is, you should know, number one, but if you don't, it's okay. This is a good time to know. This is basically a marker of innate immune activation. So activation from the innate immune system, and it's specifically tapping into elevation of proteins or cytokines that are released from the innate immune response. And when these specific cytokines are elevated, we start seeing degradation of the blood-brain barrier. So the blood-brain barrier starts to become leaky, and so that puts the brain in a pro-inflammatory state. And then it puts the brain under a lot of stress, because now you have things coming into your brain that may not be warranted, or they should not be going in. And so, yeah, if you have someone that's showing chronically elevated MMP9, any doctor should think, this is not right. This should not be there. We should further investigate what's going on there. This is the general breakdown. And the take home here is, in terms of the findings, is across the board for most of these markers, really for all the markers, you see statistically significant changes. For most of the markers, you see the numbers going down to the point where they're statistically comparable with the control numbers. The only markers where you don't see that is MSH is really the big one, and to some degree also both VIP and MSH. Mm-hmm. Both of those are showing changes in the right direction. So the treatment seems to be impacting these markers in a positive way. But the authors do make note that, for example, with MSH, the highest number, which is 18.2 at 18 months, that's still considered somewhat low. And again, this is an average. It doesn't mean that everybody was showing an MSH of 18.2. It means that some people showed higher levels and some people showed lower levels. And when you average that, you get an 18.2. And they do make note that this is an important thing to keep in mind, where MSH is going up, but it's not showing that increase that's comparable to the control group, which is 37.2. And that sits right above the lower threshold of the reference range, which is 35. Anything below 35 is historically considered clinically low. So if you have 35 or higher, that's considered normal, but the patients are not showing that. And this has been part of an ongoing discussion among clinicians. How do we raise MSH? And I've certainly participated in some new research where we start getting some answers as to why don't we see MSH levels always going up to the levels that we want them to see. And there are really good reasons for it. So we have new data there, but that's outside the issue. Just to let that overall, these markers are normalizing according to the data, with the exception of a few of these where they're still going in the right direction, but they're not quite the same as the healthy control numbers.
Then in the written description, it looks like they explain a little bit about the different therapies that they use with the different biomarkers.
Yes, and one thing, the last thing I think we can use this to start wrapping up is related to that is the other thing that I always enjoy seeing in a paper is whenever they point out when they're wrapping up and they're having a discussion about the results and how to interpret them, is there any points where they point out limitations of the study or limitations of some of the things that they're looking at? Because like I said at the beginning, no paper is perfect. Every paper has pros and every paper has limitations or challenges. And one of the things that they mentioned, which is not necessarily a limitation of the paper or the study itself, but it may be a constraint of the treatment, and it's important information. They say at the very end of that same page, so page 4 on the right column, they say presence of any of the of 3 parameters was associated with reduced efficacy. And so they mentioned depressed visual contrast sensitivity. Number 2, measurement of fungal DNA in settled dust using qPCR that resulted in an environmental relative mold index of 2 or greater. And number 3, presence of multiply antibiotic resistant biofilm forming coagulase negative staphylococci markans. So what they're saying here in simple terms is this treatment we've seen in other settings, clinically, it's not part of the study, but in other settings, we've seen that this treatment doesn't work as well if any of these 3 things are in place. So number 1, if the patients are failing the VCS test. Number 2, if there's an elevated ERMI score from the environment with mold species. And number 3, if there's presence of MARCoNS in the upper respiratory tract. So that's really important information, even though it's not something that's part of the study per se. It's introducing additional information that people need to keep in mind when they're thinking about this protocol that's being proposed in this paper, because this is really a formal introduction of the Shoemaker protocol as we know it today. And so here's important information in the discussion where there are constraints to the protocol. If you don't take these things into account, you may not see the desired outcomes.
What's coming to mind for me is different people online that you see maybe saying that the Shoemaker protocol doesn't work. And
Exactly.
you wonder, okay, are they actually out of exposure? Did they look at MARCoNS? Because we know there are other medical groups that are not addressing MARCoNS or all of the different types of environmental issues, including actinomyces and endotoxins. There's such a hyper focus on mold. And then people are saying the Shoemaker protocol doesn't work. Are you actually addressing these 3 pieces?
Absolutely. And so this is where discussion sections are really important, because what you're doing in the discussion is qualifying your results. You're putting context into your results. You're generating some interpretations. And that's exactly what this is doing. It's just that it has a very clinically oriented twist. I'm used to reading discussions that are much more theoretical, but this is like an immediate clinical implication, right? A caveat to keep in mind. And obviously from the perspective of the patient who says, this treatment doesn't work, are you sure you're not dealing with any of these factors? Maybe a doctor, a non-CIRS doctor is going to be, okay, I'm going to run the experiment, and they're trying to falsify the protocol. If they're not taking these things into account, there's a high likelihood that they may run into an easy falsification of the protocol, but not a genuine attempt of falsifying the protocol, because they're missing on this context. The last thing I'll say about this, which is I think it's very small in relation to the paper, but I actually enjoy these kinds of little things. They talk about the fact that in table 2, you see this, vitamin D levels, they were tracking vitamin D, which is not part of the diagnostic criteria for CIRS in terms of biomarkers, but they were tracking vitamin D in this cohort. And what was really interesting and unexpected from the author's end is that the vitamin D levels were, number one, very low compared to the control number. So 38.4 for controls, 19.4 for patients at baseline. And with the VIP treatment, those numbers went all the way up to 39.3. So basically statistically comparable to control. So the VIP treatment normalized the vitamin D levels. And what I like about this is that if you read at the very end on page 5 on the left column, there's a sentence that says the normalization of vitamin D3 levels was unexpected, suggesting additional but as yet undefined upstream aspects of VIP. So that's really cool because they're being very honest. These authors are saying this is a serendipitous finding. We weren't predicting this necessarily, but it happened. So what they're saying is there's a lot more here to unpack that we don't fully understand. And I always appreciate that from a paper because it is showing some level of humility and transparency in the thought process. And that to me, it's a very subjective qualitative feature that I think it's important in a good, well-written paper. But if I'm a reviewer and I start seeing things like this, that puts weight in my judgment of whether I want to accept a paper for publication or recommend it, or whether I'm leaning more towards rejecting it. I think this covers all the basics. So just to summarize, it's the very first paper. And so that's, I guess I should say this, right? This is the first paper doing this. When you're the first at something in science, it's groundbreaking. And it doesn't matter if it ends up being wrong down the line. In this case, it's clearly not wrong in terms of the treatment. But when you are putting something like this in a published format and you're the first to show this, that in on itself, you should be reading it, even if you're skeptical. So this is the very first paper where they have a case definition for CIRS patients, right? They have a criteria that's been already established in the previous decade leading up to this paper. And they are able to show in a longitudinal fashion how part of this treatment, the very last step of this treatment, which is the peptide, can actually correct these biomarkers. And so we can go back to that original motivation of this paper, right? Which was one of those really big motivations was we don't have good biomarkers. We don't have a case definition in terms of biomarkers objectively defining this illness. And the fact that you have biomarkers that are abnormal and that they respond to this treatment, that together gives you the conclusion, or it gives you very strong evidence that we have a really good map of what this illness is and how it can be treated. So this is really the first paper showing that. Prior to this, there were papers showing improvements with cholestyramine and some of these biomarkers, but it has never been shown in terms of correcting all of these biomarkers together. And especially certainly in the context of correcting the immune markers that become dysregulated in CIRS, because we now know that, again, CIRS is an immune reactivity, immune dysregulation problem. And in order to get these people to feel like normal again, you need to fix that. And up until this point, that was still an open question. How do we really get the immune system to go back to normal? Right? We can get people to feel better, but that's not the same, objectively speaking. And this is the first paper to do that. So that's really important.
That's such a strong point to remind people of. I hope that people listening can take from this that you can use what Christian has pointed out to your advantage to get what you need as a patient, and to really prove to yourself as well that the protocol works, maybe in times that you're doubting if it does, because I know we go through that at some points. And it's really good to see in black and white and to know how people have approached this and looked at this to move things forward in that regard to get what you need and to feel confident in what you're doing.
Yeah, absolutely. And just also for those who are listening, vasoactive intestinal peptide is currently being studied in clinical settings, clinical trials for things like COVID. It has already a publication track, right? And this is just a bonus. If you're a doctor and you're seeing this paper and you know anything about COVID, you may know already that this peptide is currently being studied pretty heavily in different communities. So that already should alert you to being open to reading this paper.
We are coming to the end of our time. I have one just final question for you. Outside of the paper, I often ask my general questions, but I'm going to make this more research-based. What do you really wish to see in terms of topics studied within the surviving mold CIRS community moving forward?
That is a huge question. I have different ideas personally, and some of them I think are more personal, and some of them I think are more, this is what needs to happen to move forward. I think there's multiple areas here, so I don't think it's just one thing. So at one level, Dr. Shoemaker has created this incredible path. When he published this paper in 2013, and virtually every paper he's published, the contribution of that to science and medicine is so big that you read these papers and it reads more like something that you would read 30 years from now. So this is a great thing, and it has a flaw or a negative side, which is if you're publishing stuff that's too into the future, which is what's happening here, but it's by necessity, what can happen is you've laid out this very futuristic map scientifically and medically, and then people can't quite follow.
Yeah.
And so one way to circumvent that issue is we got to go back into the basics and see what are some of the details of some of these papers, because a lot of these papers have a bit of a huge leap in terms of the data and the claims and the ideas. And so what we want to do is we want to go back and see where are pockets where we can further strengthen these claims. To answer your question, on the one hand, what I think we need to do is we need to go back into some of these canonical papers and just do follow-up studies where we're replicating or we're expanding a little bit more with more newer data that's maybe even more compelling. That would fall under the category of replication and confirmation-driven science, where we're just going back, revisiting all these foundational papers and we're expanding on them. And that often generates more credibility to these ideas. I think that's one area where we need to work on, is just go back. It may seem obvious, it may be simple for us, but it's certainly not obvious to the rest of the world.
Yeah.
So we need, ideally, if we're looking at MARCONs, if we have 5 published papers on MARCONs and how that is involved in this illness, that would be amazing. And that would put a lot more weight on the original publication on MARCONs and MSH. So that's, I think, the very first step. Aside from that, personally, I think one of the most scientific outlets is the brain piece. Thinking about how CIRS impacts the brain.
Yeah.
I think there's a lot more that we can do to understand how this illness is impacting the brain. And I know, for example, Dr. Andrew Haymond, he's heavily involved in research right now looking at traumatic brain injury and CIRS. And I think he's really thinking, he wants to put the hypothesis that CIRS is a form of traumatic brain injury. And if we just look at the brain and what's happening to these patients' brain, it looks like a traumatic brain injury profile. And so there's a lot of stuff that we can do there. And right now we're just really relying on the Neuroquant, which is an amazing tool, but that's just one way to measure brain abnormalities. And there's a lot more that we can do to really understand that. And that can help us understand so many things about outcomes with patients. Depending on the brain profile, what is your most likely outcome in terms of disease or in terms of recovery and things like that? For me personally, I think that's a very important research outlet that needs to keep going. And of course, there's the transcriptomic, the gene expression work that's been spearheaded by the GENIE test. That's the future of medicine, probably. So that's going to become at some point in the future, in my estimation, a very foundational way to measure disease, all kinds of different chronic illnesses and chronic disease. I think we're already starting to enter that path. I still think we're at an extremely early stage. And I think that's what Dr. Shoemaker is really trying. He's trying to create a roadmap for the GENIE test so that there are basic pieces of the puzzle laid out so that other people can follow through and start scrutinizing that layer more. So those are the areas that I think, 3 areas basically. Number 1, go back to the not to the drawing board, but just go back and fill in the gaps with replication and confirmatory research. Number 2, delving more deeply into the brain. And number 3, thinking about expanding GENIE and transcriptomics and gene expression and chronic disease.
I love that answer. My wish list, piggybacking off of that, would be, I think it's so fascinating that we have these imprints on GENIE that we can say you're being exposed to mold or actinos or to endotoxins and various other general markers for infection and things. I would love to see if there's any sort of patterns for particular tick-borne illnesses outside of Lyme. Is there a Bartonella pattern? Is there a Babesia pattern? Putting together the puzzle pieces a little bit to show, validate other people's experiences. And my other big wish would be just coming from the woman's experience and knowing how difficult it is for women to conceive, or when they go through miscarriages, endometriosis, reproductive issues, hormonal issues that vary from a male body. It would be really cool to start to get some research that points to how the inflammation and the exposures can really impact these areas so that women can get what they need earlier, because they might be being exposed, and when they're trying to get pregnant, it's a big red flag. It's not them. It could be their environment where they can't bring a big term.
So those are 2 really important points, and I could expand on that even a little bit more, and maybe, I don't know if this is the right time, but you and I know the tick-borne infection piece very closely, and clearly this is a big challenge in the CIRS community and outside the CIRS community. This notion that you can have chronic infections that are not going to reveal themselves to this current testing that we have available so easily. I think, and I'll say this for doctors out there and for any researchers who are involved in this, I think this is really a humbling lesson. You have to be very careful with how much weight you put into a test. I don't think it's very wise to assume that if a test is not showing you what you're looking for, that it's because you don't have it. It's a very tricky thing. I think it's always healthy to assume that tests are what they are. They're toolkits, they're imperfect toolkits. Technology is constantly evolving. To assume that a test is as good as it is and that you trust that test with your life, I think that's not a very wise way to think about tests. I think doctors need to be very dynamic in that sense, and they need to rely on other skills whenever they're thinking about complex scenarios like people with chronic tick-borne infections. You need to think outside the tests. You have to think outside the box. And my hope is that in the future, this becomes more the norm in the way we think about really CIRS, but tick-borne infections, I think, are at the forefront of this problem. Because even in the CIRS community, we're having challenges in diagnosing these correctly. And so this is my message, really. I think it's really important to understand the constraints of testing and the constraint of measurement in science is always very flawed. So we're always dependent in the degree to which the measure is appropriately addressing the thing that we think it's addressing. But the reality is that there's always a margin of error, and in some cases it's a big margin of error, and that's okay. But you just have to have the humility to acknowledge that and even communicate that to the patient.
I'm sure you can understand the depth of Christian's experience from hearing him talk about his research background and devotion to the CIRS community. If you are looking for somebody to help sit down with you and understand your Neuroquant or your GENIE in more detail, Christian is definitely the person to book in with. Sometimes our doctors don't always have the time to sit down and do a deep dive into all the intricacies and details you can really pull from your own Neuroquant and GENIE. If you want to connect with Christian, he is doing consultations. Christian, can you just share a little bit about your CIRS Lab community and how people can get in touch with you if they want to do a consultation?
Yes, so we have a membership communities called CIRS Lab. There's a few emerging CIRS communities, which is great. I think that's fabulous, and I'm so happy to be part of these different communities. And I know, Melanie, you have yours. The CIRS Lab membership is a space where we actually do a little bit of what we did in this episode. Really, the goal, or one of the goals of this membership, is to provide a kind of support that sits on the idea of empowering patients with information. Because I do believe very strongly that there is a way to empower patients with information so that information is no longer perceived as overwhelming or you don't know what to do with it. And so the CIRS Lab membership is a space where people get community support along their treatment with the Shoemaker protocol as they're trying to navigate everything. And we want them to make very well-informed decisions in that process. And a lot of it is just understanding some of the basic concepts, the basic ideas. So there's going to be some of that is going to be geared to just how do you survive as a patient? Because I'm a patient myself, I've had to do a lot of things on that front to survive the illness. Then on the other end, we talk about educational content. We talk about research sometimes, we talk about podcasts, things that are highly informative. We try to think about all of that in a way that's useful, in a way that really feels empowered. That's really what the membership, I think, is primarily about. And we would love to see you there. The link is www.cirslab.com. And you can also email us at thecirslab@gmail.com for questions or for consultations. And we'd be more than happy to talk to you.
Thank you so much again for being here, Christian. It's a joy about a year later, not even a year later, to see us both in very different places in our CIRS recovery and still a part of the community. I'm so excited to see how things are growing for you.
Thank you, Melanie.
Thank you for listening and for your kind attention. To keep in touch, follow the Heart of CIRS podcast on Instagram. You can visit melaniepensack.com/the Heart of CIRS to donate. Your generosity helps to keep this podcast growing. May the awareness of CIRS spread far and wide, helping to change millions of lives for the better.